For this trinomial, I'm going to show you how to factor it through grouping instead of the bottoms-up method. We're still going to use our railroad crossing organizer to help us figure out what values will multiply to 3 times 7, so 21, and that will add to 10. In one of my previous videos, I talked about how now that our coefficient in front of m squared is not 1 anymore. It's more than that. It's 3. So we can't just put 7 in the top anymore. We must take whatever that value is in front of the m squared and multiply it by our constant. So 3 times 7 gives us 21. Here, it'll be a lot easier to figure out all the numbers that multiply to 21 that add to 10. So we know the combination of numbers that multiply to 21 are 1 and 21, 3 and 7, and that's it. So when we add these together, we can see that 3 and 7 add to 10. So we'll go ahead and put 3 and 7 in the following spots. Now this is where our problem differs a little. We're going to start off by the grouping method. So I'm going to write down my original trinomial again. And what we're going to do is we're going to take these values of 3 and 7 and we're going to replace them in the spot of the 10m, because we know 3m plus 7m does add to 10m. So they're replacing the 10m spot. So we can bring down the 3m squared already, and we can bring down the 7. Now when you factor through grouping, you are really grouping together 2 of the 4 terms at a time. So I'm going to group together my 2 first terms, and then I'm going to group together my 2 later terms. And I'm going to see if there's a greatest common factor I can pull out of each of these. So in 3m squared plus 3m, I can pull out a GCF of 3 and m. So then I want to go ahead and write what I have after I pull out that GCF to the outside. I'll have an m plus 1. We can do the same thing for our other 2 terms, 7m plus 7. We can pull out a positive 7 as our GCF, and then we can go ahead and write what's left over, an m plus 1. When you use the grouping method to factor your given trinomial, your goal is to make sure that these 2 parentheses, or those 2 binomials, are the same. So we're going to take and write down one of them, m plus 1. That's a little hard to see. Let's make it a little darker. M plus 1. And then we're going to take our GCF terms that we pulled out, and we're going to put them in another parenthesis. So we're going to put 3m plus 7. And therefore, we have our resulting 2 binomials. This is going to be the simplest factored form that our given trinomial can be. Now let's just say you want to check this, just in case. So I'm going to use the FOIL method to show how if I multiply these 2 binomials back, I'll get my original trinomial. So FOIL, the f stands for first, so I'm going to take 3m times m. That gives me 3m squared. Then I'm going to take my outer terms, my o, and that's 7 times m, so I get plus 7m. Then I'm going to take my inner terms, which is my I, which is 1 times 3m, so I'm adding 3m. And then L stands for last, which are my last terms, which are 1 times 7 to get 7. We can go ahead and combine like terms so that our resulting trinomial will be 3m squared plus 10m plus 7. If you look at the original problem, this one does match it.